Hello, in this video we are going to talk more examples about bearings, but this time we'll record these examples as practical problems. Refer to your book. They are called practical problems because will involve bearings and also some distance. Okay, some so-called real-life examples. So to do the following examples, actually the tools you may need to use is, of course, the first one, bearing. The second one, since will involve some more distance, some lengths, so to relate the angles, the angles in the bearing and the distance, we need to use sine, cosine, tangent. And one more thing, alternate angle, of course, maybe. And the fourth one, possibly we'll use Pythagoras theorem if we need to calculate some lengths in the right angle triangle. Okay, so we'll mainly use these four tools to calculate the following two level 1 examples. So the first one, you may pause the video and read the questions yourself. We need to find the compass bearing of A from C. So you can draw a cross on C, and the compass bearing of A from C means you need to find out the value of this red angle. Okay, you need to find out the value of this red angle, which is outside of the triangle ABC. So the first one, you can use alternate angle. There's one alternate angle, and find that, okay, this angle equals to the red angle. Both are red, they're equal. Okay, equal to 9 maybe. And then you need to find out the right angle here, inside the right angle triangle. This is right angle triangle because this is still north and this is still west. So this one must be a right angle. So you have the right angle triangle, you have the sine, and you need to find out this angle. To relate these three things, you can use tangent ratio. Okay, so the solution can be written as this one. The first one, let me name this one as x, this one as y first. Okay, refer to the figure. Tangent y equals to 25 divided by 20, tangent ratio. Therefore, y is 51.340. And then you know that x equals to y, so it should be 51. Also. And the reason behind actually is alternate angle. Okay, you know it. And then finally, therefore the bearing, the compass bearing of A from C is in something E, and you need to correct the angle to nearest stable point 1. Therefore this one should be 51.3 degree. Okay, not a difficult one. So you can see that you need to use these four tools, then you can tackle the problems. So I move these four tools to the next example also. Okay, read the questions yourself. So this time you can see that find the shortest distance between the bicycle and the dog D. You need to find out the shortest distance between the bicycle because the bicycle is moving along this path. Okay, the orange one is the path of the bicycle, and then the dog is here. So actually the distance between the dog and the bicycle is changing. Okay, when the bicycle is here, this is the distance between the dog and the bicycle. When the bicycle moves, maybe arrives here, then this one will be the distance between the dog and the bicycle. So and so forth. When the bicycle is still moving to here, then this one will be the distance between the bicycle and the dog. So where is the shortest distance? In what position of the bicycle the distance between the dog and the bicycle will be the shortest? The answer is the right angle one, perpendicular. Okay, for shortest distance, you need to know it. Actually, always refer to the perpendicular distance. just think about if you have a wall here and you are standing here. If you need to walk to the wall, the path you choose must be this one. Okay, just go straight to the wall, the perpendicular distance, because you know that actually this is the shortest path you need to walk. I don't think that you will walk in this way. Okay, so perpendicular distance, the shortest one, this one. Always know that perpendicular distance refers to the shortest distance. So this time, go back to this question. You need to find a shortest distance between the bicycle and the dog means when the bicycle arrives a position here, such that the distance, the length between the dog and the bicycle is perpendicular to the path of the bicycle. So you need to find out the distance of the red line here. So according to the picture here, this is 20 degrees, so this part must be 70. The sum of them is a right angle, you know that. Therefore, in this right angle triangle, you need to relate the 5 meter, you know, the 70 degree, you know, and the question mark you need to find together. And this one is the side ratio. It's the side ratio. So you can finish the question now. Okay, so this one, refer to the figure. Okay, as you write down, refer to the figure, I will see all the hints, all the information from your figure. So keep your figure to be clear and draw all the information. For example, this one is a right angle on your picture, okay? Otherwise, I don't know that, okay, D is perpendicular to the path of the bicycle. So now, D over 5 equals to the side ratio x out. I have to find out x first. Okay, x equals to 19 minus 20, which is 70. Therefore, sine 70 degree equals to D over 5. So D is approximately equal to 4.69, and this is the final answer, and you need to find out two significant figures. So 4.7 is enough. 4.7 is enough. Therefore, the shortest distance, right, once again, between the bicycle and the dog is 4.7 meter. Okay, so these are two level 1 questions, and you can see that in these two level 1 questions I used bearing, sine, cosine, tangent, these two choose, and for these two maybe they are used for level 2 questions in the next video. Okay, bye.